Okay, today we're going to solve some physics problems. So, we have our first problem that involves a pulley. We have our mass 1, right? Mass 1 right there. It is attached to a pulley that leads to our mass 2. And so, we have our mass 1 that has a 10 kilogram weight. 10 kilogram mass, sorry. And M2 that has a 5 kilogram mass. And now I have to find the weight of each of these two objects. So as we know, weight is mass times gravity. So we have 10. Right here. We have 10 times 9.8. That gives us 98. And for the other one, we have 5 times 9.8. That gives us a 49. Yeah, 5 times 9.8. So, after we have the weight of each of our masses, this is our mass 1 and this is mass 2, objects. We then have to use the formula, which is Fk, which is for kinetic force, equals mass times acceleration. And we also need the displacement, which is so initial t plus 0.5 acceleration in time square. So after solving each one of these, starting with if we have, we should get 2 equals A1 0.44, and then after we pass to the other side, we have acceleration equals 1.39 meters per second squared. So these other things. Yeah, now I have to also do a free body diagram. So I'll do it right here. Actually, we're just going to find the forces in Fy and Fx, and then on Fn. So for Fy, we know that it equals 0. The net force minus 98 minus F equals 0. So it's not 0 because it isn't 0. So net force of this one is 98, and then we have for Fx equals n mass times acceleration. So for this one we have ti minus f k. So this is 10 times 1.3. So now I have 42 on 1 minus fk, because it's tension 1, minus fk. This equals 13.9. I think it was 9.39, I'm sorry. 13.9. So the kinetic force in this one would then be 20. So the last one was a final of 28.2. Sorry for that. And now we're gonna move on for another problem. There were 2 problems. Now we're going to the third one. So for the third one, we have our diagram, right? Let's see how I can use the marker. What it is. Oh. We have various tensions here. First of all, we have our T3. We have our T2X. We have our T2. Our T1. And our sorry for that, T1X. Then we have T1Y and T2Y. So these are the one without the values added on it. So the problem says that T3 equals 600, sorry. 600 newtons. And T2 equals 37. And so I think we're going to use the one for fx. Well, I'm gonna erase this. Keep that right there. I'm gonna do it right here. So you have fx equals T2x. Erase this, put it somewhere else. Go right here. T3 equals 600. T2 equals 7 was. Yeah. So now the formula is 2x minus T1x. So we know that T2x minus T1x is equal to 0. So we will grab T2, cosine of T2 of 37 in this case minus T1 cosine of 0 8 equals to 2. Cosine of 0 8 equals to 0. So we have 0.8 T2 do this minus T1 because it's T1 minus 0. And the only thing we can conclude here is that 0.8 T2 equals T1. Switch it, we have T2 1.25 T1 and finally the T2 equals to 428 or 58. So that's T2. And we can do the one in Fy. Fy equals 0. And then we have, then after that we have T2y minus T1y, T1y minus T3. So you grab T2 sine of 37, which will be T2x. We'll grab plus T1 equals T3, which in this case is 600. Now 0.6 T2 plus T1 equals 600. And it's 0.75. I'm just going to jump ahead to 1.775 because the other one, T1 of course, equals 600. T1 because it's the one we're looking for. Ooh. So if we pass it to the other side, we have T1, sorry, the other one, T1 equals 342.86. So yeah, that's it for the for the second one. And to the fourth and last one. It is basically the same thing. Finding the 4 T's for tensions problem. So we have T3 equals 150 newtons, of course. So yeah, let's get to work. Start off with finding T1. So we have a Fy. Of course, we shouldn't be this because it's confusing. We have a T1y, so C2y. Equals C3. So we have T1, and you know the y is 0.87, because you have to do the cosine and sine and everything. That's how we know the values of these numbers. Plus 0.5 T2, and it equals 150. And then we have 0.87 T1 plus 0.29 T1 equals 150. And we have 0.3 T1 is 150. All we have to do, write this. I think no. That's 0.3 T1. And for this one, and to be tension 1 is 405. Addition 150 divided by 0.3. We have close 500. And this is our tension 1. Now to T2, is this one more and final time. We do have T2x minus T1x, of course, will be equal to 0 to the moving next. That's 0.8. 7, sorry, T2 minus 0.5 T1 equals 0. Sorry. It equals 0. And then we have 0.87 T2. And since we move this to the other side, we need to move it. That's 0.5. It equals to 0.5 T1. And then we leave T2 alone and 0.57 T1. So we can conclude that T2 equals 231. It says 0.8. That was my final answer in the calculator. Newtons, of course. And we already know that T3 was 150. So that concludes, finally, our session of physics problems. Thanks for watching.